So the question, membranes are commonly employed to separate gases. Consider a membrane system designed to separate nitrogen and oxygen from air. The feed stream entering the membrane consists of 21% of oxygen, 17 and 79% of nitrogen. The permeate system stream after separation has 25% of oxygen and 70% of nitrogen. If the waste stream, which is W, accounts for 80% of the feed stream, determine the mole fraction composition of oxygen and nitrogen in the waste stream. So first we draw the block diagram and we assume the feed is 100 mole per second. So if the feed is 100 mole per second and the question said that the waste stream account for 80%, so the waste is 80% of 100 mole, which is 80 mole per second. So if the waste is 80 mole per second, so the permeate will be 20% mole per second. So from this we can find for the permeate. So 0.25 times 20 mole per second will be 5, and for the nitrogen, so will be 15. And then from the permeate we also can find for the waste. So if the feed is 21 mole per second and the nitrogen is 79 mole per second, so we can find for the waste. So for the oxygen, 21 mole per second minus 5 mole per second, and then we got 60 mole per second. This is for the oxygen. So then for the nitrogen, 79 minus 15, we got 64 mole per second. And then we can find for the mole fraction. So mole fraction for the oxygen, for the waste is 60 mole per second times total of the oxygen and nitrogen, which is 60 plus 64. So we calculate. We got 0.2. Then we find for the nitrogen, 64 over 60 plus 64. We got
Assalamualaikum and good morning. Today I would like to represent the recycle structure diagram. First of all, the question mentioned that the fresh feed of reactant A is 100 kilomole per hour. So we're gonna write here fresh feed is 100 kilomole per hour. Then it says that the reactant A will combine with the recycle stream R. So we're gonna write here R, so it can be our reference. Then we gonna separate the all B at here, so the recycle will only contain A. So we gonna get the total flow rate is 100 plus R, and we gonna remove 20% here, and we gonna get only recycle remaining is 80% here. So we gonna calculate how many kilomole of reactant A into the reactant.
Okay, for the calculation, we took the R equation. R equal to 0.8 times with 0.4 times with 100 plus R. So we solve the equation and we get the R equal to 47 kilomole per hour. So for the total flow rate is 100 plus R. So R is 47 we plus with 100, and we got the final answer is 147 kilomole per hour. That's all.